Hi all, welcome to my channel. Today we are going to discuss about the week 1 assignment NPTEL questions. Okay, so already I submitted some week 1 assignment questions. Now we are going to see very first question. Okay, so what is the first question? Which of the following statements is correct or correct? So first A, physical level abstraction describes how record is stored. And second one, view level abstraction hides the details of data types. And third one, physical level abstraction describes the data stored in database and their relationships. Fourth one, logical level abstraction defines the physical schema. So remember, it is about the levels of the data abstraction. So first one is physical level, second one is logical level, and third one is, so first one is physical, second one is logical, third one is view level. Okay. So the purpose of physical level is it is used to describe how the data is stored. When I say logical level, it shows the what data is stored. And the third one, view level. So it shows something like it hides the details. So these are three are important codes for physical, logical, view. So according to the options given, physical level describes the how record is stored is correct. And if you see view level abstraction hides the details of data types, okay. And if you see third option, physical level abstraction describes the data stored in database and their relationships, it's wrong. So when I say relationships, the relationships will be coming in again logical level. Next, third option, what we have? Logical abstraction defines the physical schema. Wrong. So this answer is A, B. I hope this is clear for everyone. Now I am going to second question. So what is the second question we have? Consider the following relations, subject and faculty. So they mentioned subject and faculty. So there are two tables. First table name is called as subject and second one is called as a faculty. So remember, there are two tables. First one is subject. So total subjects fields are SID, SName, and credit. And if you see faculty, in faculty, what we have in faculty ID and SID. So they are going to ask RA1. So they are going to mention this pi subject dot SID. So comma SName. So they are going to join subject and faculty. And this is called as natural join. This is called as natural join. And in the second one, pi subject dot SID SName subject faculty. This is called as cross join. It is also called as a cross product. So they are going to ask what is the natural join between subject and faculty. What is the natural join, cross join between subject and faculty. So let us finish these details. Let us assume SID is 100 and S name, student name, something like Ramu, credits 4, and student ID next 101, and Ram and faculty name something like Raju, and credits 4. And this is a first table. And in the second table, what is going to be happened? I'm going to write faculty ID 1 and SID. Let me take here 101. Faculty ID 2 and SID 103. So I have mentioned two tables. One is subject, second one is faculty. So they are going to say natural join. When the natural join between subject and faculty, remember, very, very important. When the natural join is between subject and faculty, it takes only the common values. If you see, the common value is here SID. So the common values between these two tables are SID. In between these SIDs, what is the common value? Yes, the common value for this subject and faculty is 101. So remember, when I say NS cross join F, so sorry, S natural join F, it is going to give the SID, and it also gives S name, and it also gives credit, it also gives FID, it also gives the SID. Now, if you see, the common value between these two are 101 only, 101. So remember, it gives 101 Raju and credit 4, and faculty ID is 1, and this value is 101. So remember, this is called as a natural join. Now, if I say cross join, so what is going to be happened when I say cross join? So remember, cross join. If I say cross join again, S cross F. So I'm going to say now cross join. So remember, now we are talking about the cross join. So what are the fields under the cross join? Again, it comes under SID, and it come with the S name, and it come, let me take some other space because I think this space is not good enough. Yeah, so let me write here SID, S name, yes, SID, S name. So I'm going to cross join SID, S name, credit, and FID, SID. So FID, again SID. So remember, no need to write this because already we write once. Yeah, so FID. So now what I'm going to do, I'm going to do, so remember, now we are talking about the cross join. So in cross join, 100 and Ramu, and remember, this value is 4. So here, when I say cross join, 100 Ramu 4, it will get the value as, so here you need to write, we need to write FID. Okay, 100 Ramu, FID is 1. So second, again, you get in cross product 100 Ramu, 4 and 2. So this is called as a cross product. When I say cross product, what is going to be happened, I will explain, don't worry. So now 101 Raju, 4, 1, 101 Raju, 4, 2. So remember, when you have this cross product, so 100 Ramu, 4, it will connect with FID first and second. That's why we have 100 Ramu 4 1. And again 100 Ramu 4 2. So 2 times it will come. 100 Raju 4. It connects with two values. One it called as 1 and second one is called as 2. So that's why again on 101 4 1 101 4 2. So this is called as a cross product. This is called as a natural join. If you see the relation between these two tables, so they are going to ask whether RA1, so let us write, yeah, this is called as RA1. This is called as a RA2. So they are asking RA1 is subset of RA2. So here they are asking RA1 is proper subset of RA2. RA2 is subset of RA1. RA1 is subset of RA2. RA1 is equal to RA2. So let us come with the last one. RA1 is equal to RA2. No, because when I say cross join, they are going to give all the values, and when they have natural join, they are going to give only common values. Hence, this option is wrong. Now, remember, there are two terms. One is called as subset, and second one is called as a proper subset. If I say 1, 2, 3, the subset elements are 1, 2, 3, 1, 2, 1, 3, 1, 2, 3. So these are called as subset of elements. So if I say a proper subset, so they are going to have something like 1, 2, 3, and 1, 2, 1, 3. So these are called as proper subsets. So remember, now we are going to check whether RA1 is a subset of RA2 or RA1 is a proper subset of RA2. RA1 is a equal to RA2. So remember, now if you see the natural join, we have only one value which is called as 101 Raju 41. If you see here again, 101 4 Raju 1. So this natural join will get more results, and this cross product will get more results, and when I say natural join, it will get only common values. Hence I am going to say RA1 is a subset of RA2, because when I find RA101 Raju 4, it comes here. 101 Raju 1. So I am going to, this is called as a subset of RA2. I hope this is clear for everyone. Let me go to next question. Yeah, so it is a very, very, very important question. Actually, this answer is option 4. Let me take whiteboard for this one to better understand this one. Now we are talking about the question number 3. What does the following relational algebra expression returns? So they gave some relational algebra and they asked what is the option for this question. I will explain this one on board. Now, if you see what is the following relational algebra returns. So they gave projection height mountain, projection mountain dot height, and selection mountain dot height less than height mountain, and rename of M mountain. Now we'll see how to this how to do this problem. So remember, they give three symbols. One symbol is called as this one. Second symbol is called as this one. Second symbol is third symbol is called. So this is called as a. This is called as rename. This is called as a selection. This is called as a projection. So this is for selecting the rows. This is for the selecting columns. This is for the rename. It is for rename. Now, according to the question, so first we need to take one table. The table name is called as, here if you see, mountain, and rename M with mountain. So remember, first we need to establish one table name is called as mountain. Now they are going to ask the attribute is called as height. So what is the name of the table? Name of the table is mountain, and attribute name is called as a height. Why we choose an height? Because if you see in the question, always they ask about the attribute height. If you see height of mountain, if you see here, mountain dot height, mountain dot height, M dot height. That's why we are choosing one attribute name is called as a height. So the values are 100, 300, and 450. Now, what they are going to ask? So this table name is called as a mountain. And I'm going to take one more table name is called as M. So remember, they are going to say rename of M. So rename with M. The table name is called as mountain. Means the mountain table is again one more copy. The data is same 100, 300, 450. Now, so till now, we finished till here. Yes or no? Yes. So till we created mountain table and we created M. So with a rename of mountain with M. Now you need to take the cross product. So they are going to ask cross product of mountain with M. So now I am going to take mountain cross product M. So if you cross product these two, what is going to be happen? So remember, I am going to take this is as, so first second table will come here. So here I am going to take mountain and second one M. So first table name is mountain, second table name is M. So I'm going to take something like mountain height and this is M height. So remember when you see the cross product, what is going to be happen? So 100 will come here, 100 will come here, 100 will come here like that. 100, then you get, so the cross product of this 100 is 100, 100, then we get 100, 300, then we get 300, then we get 450. So next one 300, 300, 300. So again, what are the values of this one? 100, 300, 450. So like this again, 100, 300, 450. Again, if you see cross product with the 450, so again 450 values will get 100, 300, 450. So now this is called as this one. So on the screen, this mountain cross rename of M mountain as a this result. So now again, what they are going to ask? They are going to ask mountain height is less than M dot height. Now if you see in the diagram, we are going to take mountain height and we should take M dot height. They are going to ask less than value and mountain dot height. So what is the mountain dot height? So they are going to ask the column values. Why? Because they mentioned that it is called as mountain with this projection operator. So mountain dot height is less than M dot height. So mountain dot height is 100, 100, 100 and M dot height is 100, 300. Now you need to compare these two when there is a less than. If you see 100 and 100, is there any less than? No. 100 is 300 less than? Yes, true. Now if you see 100 less than 450, okay. 100 is less than 450. Again 300 wrong, 300 wrong, 300, 450, yes. Now if you see next one, 450 is less than 100 false, 450 is less than 300 false, 450 less than 300 false. So now remember the final table what you have, 100 and 300. So now what we need to do, so this is a final result of this one, mountain dot height is, now they are going to ask height mountain minus this final result. Now actually what is the result of this one? Actually what is the value of mountain dot height? So mountain dot height is, if you see here, mountain dot height is 100, 300, 450. Again if you see what is the current result, this current result is, this is called as mountain dot height. 100. So they are going to ask about the minus. So if you minus, then what is going to be happen? This 100 will be crossed, and this 300 will be crossed. So final result is 450. So as per the given this one, it is a maximum height from the given mountain relation. If you see, so the maximum height. So we assumed the height values are 100, 300, 450. So actually what is the result we received? 450. Hence we can say this is the final result for this one. So we'll go for fourth question. If you see here in the fourth question, what we have. So remember, the fourth question is consider the relation schema phone book which contains a name, phone number, location, and last call. If the tuple is Ankit 425861110, Kolkata 15 July is present in the instance of phone book. Okay. So which of the following tuples cannot be inserted in a phone book? Remember, if they say something like this underline phone number, so this is called as something like a key. So a key nothing but, so it should identify the entire relation. It should identify the entire relation. So remember, already we have Ankit 42581160, Kolkata 15 and July. And in the following, which cannot be inserted. So if you see Ankit, already Ankit is there. But if you see the key is here, name and phone number. Name and phone number are 222 58610. So name and 58160. This is a not accepted because here the key value is name and phone number. Remember, if you underline here, this is called as something like primary key, which should not be a null, which should not be something like a duplicate. So already they mentioned Ankit 342581110 inserted. Again, you should not insert here. That's why we mentioned as a C. So this is called as a explanation for question number 4. Now we go to fifth question. Consider the relation flight number, source, destination, duration. So remember, they are going to ask what is the possibility of super keys. So what is the name of the table? Flight. So flight is having flight number and source and destination, and next we have duration. Okay. And they are saying flight number and source, destination, duration are called as a candidate keys. So this is called as candidate key. This is called as a candidate key. So remember here, the total number of attributes are 4 because 1, 2, 3, 4. Now we are going to find out the what are the possible number of super keys. So super keys we need to find out. So remember here we have one formula. Possible number of super keys are, so I am going to write here. This is called as a first super key. This is called as a second super key. So you need to write one this formula 2 power n minus 2 power n minus attribute in first candidate key plus 2 power n minus attribute in second candidate key minus, so remember minus, so you may have both keys, so something like 2 power n attribute in, so attribute in first and second. So this is called as a formula to establish a super key for this program or this example. Now, so here what is the this value? 2 power n value is 4 minus, so 2 power minus 1 because for one candidate key, and this is for 2 power 4 minus 2 because two candidate keys. And next one, last one, what we have attributes in 1 and 2. So this is called as 2 power 4 minus 4. So final answer is 2 power 4 minus 1 plus 2 power 4 minus 2 minus 2 power 4 minus 4. This will be minus 2 power 0. This will be 2 power 3 plus 2 power 2. So this is actually here second one. So second candidate keys values are 3 na. So you write here 3. 4 minus 3. Then we get 2 power 1. Yeah. So the value is 8 plus this is 1. 2 minus 1. This is equal to 9. So the correct answer is for this question 9. So I hope this is clear for everyone. Now I am going to take next question. So what is the next question we have? Consider the following example. So they gave PQ. So remember they are asking what are the possible candidate keys chosen. So I am going to say here PQ. So as you know, the values of this PQ, something like truth tables. So how we write this one? True, 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 false, false, true, false, false. So this is called as a PQ values. So instead of PQR, you can also write 0, 0, 1, 1, no problem. So here PQ. So I am going to write here 0, 0, 0, 1, 1, 0, 1, 1. Yeah. So now if you observe in the question, they asked R is equal to PRQ and negation P. So remember, we need to find out the PRQ implies negation P. So in order to find this one, we need to get negation P. Okay. So what is the value of negation P? 0. So instead of 0, what we can write? Already you have 0. Negation P is 1. 0. Negation P is 1. Next 0, 0. Because we have 1, 1 here. Now they are going to ask PRQ. So what is PRQ? When both are false, the result is false. And if you see here, both are false. In all other cases, result is not false. Hence, we are going to say 1, 1. When both are false. So here 0 means false, 0 means false. The result is 0. All other cases, result is not 0 because both not are false. PQ. Now, if you see PRQ implies P, negation P. So what is the value of this one? So now we are going to take, so this is called as, I am going to write directly R. So there is a relation between PQ and negation P. So remember when I say this implies, when second value is 0, then only it is going to say false. Now if you see PRQ negation, so this is implies, this is something like PRQ is implies negation P. So this is negation, this is implies, this is implies. When I say implies, when second value is false, then only the result is false. So these two cases, only result is false. Hence, I am going to take 0, 0. All other cases 1, 1. Now, what is S? So S is PRQ negation P. So this is PRQ and this is P. Now, I am going to write about the S. Okay, what is S now? So PRQ implies P. So when the second value is false again, the result is false. Only when the second value is false. So if you see here, here only the second value is false. All other cases not. So we are going to say this is called as a R. Now we are going to have 1, 0, 1, 1. Now they are asked about the what is the candidate key. If I say PR, if you see PR, just to write the PR values 0, 0, 1, 1, 1, 1, 0, 0. Now this is called as PR. This is PR. Now if you see PQ, so what is going to happen in PQ? 0, 0, 1, 1, 0, 1, 0, 1. Okay. Now what is the third option? We have QR. So how to write this QR? So I will write here QR. So what is the value of Q now? 0, 1, 0, 1. What is the R? 1, 1, 0, 0. Now what is the value of QS? So QS is QS. So QS is 0, 1, 0, 1. 0, 1, 0, 1. S is 1, 0, 1, 1. So remember, now we are going to find out the candidate key. So here, the candidate key, if you see here, it is correct because if you see, it contains all combinations. You see 0, 0, 0, 1, 1, 0, 1, 1. Again, so I'm going to say PQ is the correct answer. And PR, if you see 0, 1 is there, 0, 1 is there. 1, 0, 1, 0, double, double comes. So this is not a candidate key. Now, if you see QR, 0, 1, okay, 1, 0, okay, 1, 1, 0, 0. So this is also correct candidate key. Now, if you see QS, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 1. So here 0, 0 is missed. Hence, the correct answer is PQ and QR. I hope this is clear for everyone. Now I am going to take next one, question number 7. So now the question number 7 we are going to have. So what is the value of this question number 7? So they are going to say chart box is there. What is the name of the table? That name of the table is a chart box. So name of the table is chart box, which contains two attributes, sender ID and receiver ID. And we have one more table, chart message, chart ID, text, sender ID. So remember, this is a chart box table. This is a chart message. So sender ID, receiver ID. So chart ID, text, sender ID, another table. Remember, they have give foreign key. So here they mentioned that foreign key is the sender ID. So what is in by foreign key? It relates the two table. So whatever the data you have in sender ID, that should be in other table, same data, because we are relating two tables. So they are going to ask what is the valid chart message. So what is the valid chart message? Chart ID, text, sender ID. So if you see here, again, chart ID is the primary key. If you mention some underline, they are going to say primary key. Primary key should not have any duplicate values. So 50, 50 duplicate. So you cross this one. Primary key won't accept null values. Null is there. You cross this one. If you see in the question, already they mentioned 104, 22 is there. So in this 50, 22 is a sender ID. So you cross this one. Now this is called as 104, 22. Chart ID is 50, 104. Hence, the correct answer for this one is B. I hope this is clear for everyone. Now, question number 8. So what is going to be happened here? They are going to ask what this relation shows. Now, if you see, they have mentioned this project, this selection table. So we are going to display particular rows. So this is called as a particular rows. Now this is a table. This is the answer. So which query relates? So if you see first one, they are going to say state name is equal to Uttarakhand, okay? And altitude is 7750. If you see in the result, this mountain tab should not have any, Uttarakhand. If you see here, no Uttarakhand. Hence, this first answer is wrong. Second answer also wrong. Third answer also wrong. If you see, altitude is greater than 7750. Yes, it is a greater than values. Hence, we can say the correct answer is 8D. I hope this is clear for everyone. Next one, identify the characterization and produce the output from the following. So we have two tables. First table name is mount details S1, mount details S2. So they are going to ask what is the relation between these two. So what you need to do, just you need to minus between first one and second one. So if you minus first one and second one, so you are going to get this result. So if you see Manda Devi and so we are going to have different tuples on first table and second table. Now if you, what we are going to do, we are going to do the minus. So S1 and S2. So how to do the minus? So whatever the values you have in the second table, that will be deducted from the first table. If you see, this is in first one, so this will be removed, and Trishul is not there, Kamet is not there, Sandaku is there. So these two are there. So this will be removed. So what is the final result? Nanda Devi 7816, Uttarakhand, Sastro, Jammu, Himachal Pradesh. But if you see in this diagram, you get only two attributes. So this is not correct. And when I say S2 minus S1, so S2 minus S1 means we are going to subtract this from this one. So S2 minus S1. So again, the common things from S2 and S1 is Kancham Junga 8586. So okay, I'm going to remove this one. And Trishul Sadaku 3636. This will be removed. Now if you see, 2 will be remains Trishul and Comet. But if you see Trishul and Comet not there. So now if you union between these two, and if you get intersection between these two, if you get intersection, then this C answer will come. So if you have any doubts, really you ask me after you not getting. So this is a answer number 3. So next one, what is the candidate key for following instance? So if you see in this problem, 856. So first one is altitude, 858678. So we cannot say this is as a candidate key because the values are repeated. Mountain name, state name. Okay, state name, if you see Uttarakhand, 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 repeated. Hence, this is not a candidate key. This is not a candidate key. Now I am going to say this mountain name is a candidate key. So this is for explanation of NPTEL assignments 1. Thank you for watching this video. Please subscribe.